Hi everyone, I'm Hasan Savran. Today I want to share some great information about using Azure Cosmos DB's vector features. Lately, everyone has been talking about AI, ChatGPT, copilots, and how all these new tools make daily life easier. The most common questions asked to ChatGPT are about fact-checking, recommendations, explanations, or advice. For example, what is the best way to learn a new language? What is the meaning of life? Or write a pop song for my wife. That's an interesting one. While these are great questions, they mean little to businesses. Businesses want to ask business questions and they want AI to use their enterprise data to answer them. You may store customer service notes, reviews, customer feedbacks, trends, and insights in these enterprise databases. Imagine being able to ask questions such as list negative customer notes in California. What is the most common feedback about the product X? Summarize the sales trends in a paragraph. Or what are the most common business challenges in Ohio? You can achieve this using the RAG pattern, which is Retrieval-Augmented Generation. You need a modern, scalable, cloud-based database to store vectors and connect other cloud AI services for more features and interactions. We know Azure Cosmos DB, but as you can see in the name, there is a DiskANN out there. Well, DiskANN stands for approximate nearest neighbor. This is actually the new vector index type Azure Cosmos DB has. It is graph-based, it is SSD-based, which makes it very fast, and it is compressed. The Azure Cosmos DB team put the cherry on top of the cake by introducing DiskANN vector types to Cosmos DB. As I said before, we have the clients on the left side, and we ask a question. OpenAI gets the question and gets the data and return back to answer. That's really for a public use. If you want to use RAG pattern, then that means you are going to retrieve the data from one of your enterprise databases. In this case, it's going to be our Azure Cosmos DB. Now, to make the RAG actually work, this simple question answer is not going to work anymore. So what are we going to do? Well, the first thing we need to do is we are going to come up with a prompt, which is the question we want to ask to our enterprise data. Well, to ask the data, first thing we have to do is we have to take our data and convert to the vectors. When that is done, you need to go and index that vector. So it will be much easier to access and it will be quick. We are going to use the DiskANN vector type for that. Now, when that is complete, we can actually start ask questions to our data. To do that, well, our question is going to be a human language. Well, we need to first convert that human language to vector. So that's the first step we need to do. From there, we are going to use one of the vector functions Cosmos DB has, and we are going to pass this vector we just created. Cosmos DB is going to go and do its magic and find all the other vectors close to the vector we have here, our question. Then we are going to take that data, retrieve data from the Cosmos DB, and we are going to actually attach to one of the OpenAI parameters. Now, in this case, we have the question, we have the data, and you might even have the system message out there for OpenAI. So OpenAI actually has all the data it needs. It doesn't need to go and look at the public data anymore because we are actually specifying which data it should use. In that case, it's going to do its magic and it's going to give us back to the answer. So what you see here is really the RAG pattern. And Cosmos DB is a great option for them. Now you might say that, well, Hasan, this looks great, but it looks like, this might be costly. And do we need to kind of go and get the Cosmos DB account, the full Cosmos DB account for that? Well, just for you, I have news for you. You can actually use the serverless Azure Cosmos DB mode. This is a great option, especially for a proof of concept item just like this. It is great for the dev environment, QA environment, or the proof of concept issues like that, because you just pay for what you use in the serverless. And whenever you are ready, after you prove to your business leaders, look what we can do here with this, this is great news for the business. Let's go, and use our data and, put something in production with this. Whenever you are ready, you are not stuck with the serverless. If you need more, like scalable and more power, then you can easily migrate this to the provision throughput, and you can use all this Cosmos DB provision throughput features just for that. So we don't have to start from the scratch again. So serverless is a great option, especially for creating a proof of concept like this. Now, since we kind of explain everything here with what are AG and what we are trying to do, let's actually look at together one of the GitHub projects Cosmos DB actually has, and let's see how this thing works in the code. Well, our next step is actually show you some kind of code here, right? We talk about what is RAG pattern, and we kind of try to put in a diagram what actually happens. Well, actually, let's see some code and how actually it works. For that, well, first, I guess thank you to Azure Cosmos DB team for that, because they have a great area here under the GitHub, as you can see. GitHub.com, Azure Cosmos DB AI samples. This is the central place for Azure Cosmos DB. You can find all kind of information here, all kind of code, all kind of specific information about the Azure Cosmos DB for NoSQL or for the MongoDB. And there's all kind of code samples here, all kind of videos here. So this is really a central great place which can really answer many of your questions about AI in Azure Cosmos DB. So what I want to actually focus here is maybe we can look at one of the code samples here and actually see how it's going to work and what it does. So since we are talking in the Azure Cosmos DB for NoSQL, as you can see under the code samples, there are a couple of items here. Let's actually look at this movie chatbot for Azure Cosmos DB for NoSQL. So you can easily get the repository from here and download it and set it up and start it with no problem. That's the first time I tried it and it worked great. So we are going to actually do that together here. But really what we are going to do here is this one has some movie information, as you can see. We are going to take that information, put in the Cosmos DB. We are going to create vectors for it. And after that, we are going to be able to use the RAG pattern and search the data by asking questions to OpenAI. So everything is documented very well. So all you have to do is just get it from here, download it, and there are like two steps. First step is going to actually create all the databases, containers, and all kind of information. Second one is going to show you how the actual application is going to use Azure Cosmos DB and OpenAI and use the RAG pattern. The only thing you are going to need, you're going to need an Azure Cosmos DB service for that. And I created one for myself. So before I show you any kind of demo here, I just want to be sure that, we are going to look at one thing here. I pick serverless. The main reason I picked the serverless, because this is I'm just learning something new, or this might be a proof of concept for your company. And you don't want to, get billed for provision throughput, because you really don't need that much, resources. So in the serverless, you are going to use only, what you use. So that kind of makes sense to pick the serverless. In the serverless, though, you pick the serverless or the other one. The first thing you want to do here is, you need to go under the features of your service, and you want to be sure that vector search for NoSQL API is actually on here, because without that, the demo that I'm just going to show you is really not going to work, because it's going to look for some of the vector search functions. So this has to be on before you start. Next, I open this in the VS Code. So let's look at the VS Code here. Let's see. As you can see, there are two uh, files that you need to look at. The first one is actually create the structure. As you can see, all you have to do is here, you just click here, and this will install all the things that you need. So I'm just going to pass that for now. This is going to import all the required fields. There's not really that much going on here. So this one is pretty, I guess, important here. This is the one where you are going to actually show where all the keys and the connection strings are for the Azure Cosmos DB and for OpenAI. So since this is in Python, this kind of gave me a problem. It took some time for me to catch that, but let me actually share that with you. In here, for you can see Cosmos NoSQL connection string. This one is really not the connection string. This is the URL, and the key is here. So if you look at the connection string in the Cosmos DB keys, usually this one and that one is together. So in the C#, it can just parse those and get whatever it needs. But in the Python, even this time, this one says Cosmos DB NoSQL connection string. Just take the URL and put the URL here and put your key here. So they are kind of separated when it creates the Cosmos client. So it comes up with a sample environment file. So I create my own environment file. And as you can see, I just put all this information in it. So in this one just gets all this information for Cosmos DB and AI, and it puts all those together to create the Cosmos client and Azure OpenAI. So this one is pretty easy. It just takes time to kind of get all this information and put in a file. So that's the only challenge. Rather than that, we are after this everything is ready, we are going to create all the databases and containers. So this is the place it might give you a problem if your vector feature is not available yet. Because then it's going to say that you cannot change those policies because, well, you don't have the vector policy available if the feature is not available. So if it's available, this should be just fine too. Also, I picked the serverless, as I said before. In the script, as you can see, it says here offer throughput 1000. So in my case, since I'm in serverless, I really don't need this. That's why I just comment this out here and here. So if you have a throughput, you can keep it. But if you have the serverless like me, this will throw error. All you have to do is just comment that out and you should be good to go. From here, we are going to actually, this is the function which is going to create embeddings. So that's all it really does here. Anytime we try to create any kind of embedding for the answers, for the question that we are going to ask, or for any data, we can easily call this function and pass what we want, and this should return vector, which is a bunch of really numbers. Now, from here, as you can see, JSON file is already here. This is the data, and this is just going to load the data. And after that, we are going to put that in the Cosmos DB. So that's what's going to happen here. As you can see, store the data in Cosmos DB. And after you run that one, you should have all the data in. And really, that's it as a setup. So that means that we have the data, we have the Cosmos DB information, we have the OpenAI information. We are ready to go. So next one is we are going to look at this file. This one is the where actually I guess the magic happens, right? So this one is, as you can see, it's going to need some of the preliminaries here. We're going to just install them first. We are going to put all the imports in it. Then again, we are going to use the environment file here. So we will know what the databases, connection strings, OpenAI connection strings, so all of those are here. I'm still going to use the same exact environment. Then I'm going to create my Cosmos client and Azure OpenAI to actually, so I can call them. Then from here, we are going to get our database and collection information. Then we are creating a function here, and this is actually generating the embeddings whenever we, I guess, ask a question for the Cosmos DB. As you can see, this one just, so if, let's see if I actually run this. If I run this, as you can see, test becomes a bunch of numbers. So whenever you ask a question, your question is going to go here, and this is going to generate the embedding. And well, it's going to be a bunch of numbers here, just like this. Now, how do we make the search? So the search is going to happen. As you can see, we are going to use the vector distance function of Azure Cosmos DB, and we are passing the embedding, which is the, well, that's the question you are going to ask, and see that vector is the property that actual vectors are in. So, and we have the score, it needs to kind of be larger than score to find the data. And also, as you can see, I want top in here, or just saying 510 documents. So we're going to take that 510 documents, send to OpenAI so it can do its magic and give us the answer. So as you can see, there's really, it's pretty simple what's really happening in here. This is how we are going to actually search the Cosmos DB for vectors. And also we have the chat history. So if you're going to ask the same question a couple of times, then it kind of makes sense to kind of, cache that in some way. So this is very useful for that. This is another kind of extra function from Cosmos DB. And you can see here that's going to be the general competition. So that's the part of the program. As you can see, we are just actually calling the OpenAI. We are putting all the the prompt information here, and all the data we are going to actually put it here too. So from here, let's continue, and I'm sure you will have kind of look at all that in details here. And that's the chat competition. That's the same. We are going to create the embeddings here, as you can see. We are going to look for the cache results, and we're going to make a search. We're going to check the history. So that's all kind of things are happening here. Now, as you can see, we are going to create the generate responses for cache here. I'm just going to pass that for now. And this is the chat competition, another function here. So let's actually minimize this one too. Now, we need some kind of UI. So we have all kind of functions here that, it will be very useful for you to understand what's really happening. But, at the end, you need some kind of UI so it can run all these functions that I just showed you. Now, let's create a UX. So this is believe it or not, I mean, this is my first time I'm dealing with this Gradeo. It's amazing. It just creates an application on fly. I was like, where were you, Greg? You're in like 10, 15 years ago, right? So, but anyway, so let's run this one. So this is going to actually start an application. To start application, we are going to run the demo launch. And as you can see, we have a running application. Crazy. Now, I guess for Python, it's not that crazy. In C#, I don't know. Maybe there's an option for C# too. So anyway, the question is, we are going to ask a question here. This question is we are going to actually generate an embedding for the question. That's going to be a vector. Then we're going to go to the Cosmos DB, and Cosmos DB is going to find all the other answers close to this question. Then it's going to go to the OpenAI, give us data, and OpenAI is going to give us an answer. So since we are dealing with all the data for the movies, now let's ask some kind of movies. Let's say I like, let's see, Eddie Murphy. Suggest me a couple of his movies. Let's see what's going to happen here. Enter. Okay, it's thinking, and as you can see, we have some data. All right, here are some Eddie Murphy movies you might enjoy. As you can see, it's a good answer. It kind of gave me good suggestions here. So you can ask all kind of questions like that to the Cosmic Movie database, and it should OpenAI is going to get the data from the Cosmos DB, and OpenAI is going to answer some kind of questions just like that. So as you can see, it kind of looked there were a lot of kind of steps here, but really, I mean, this is the Python. In C# you might need to kind of do a little bit things different, but idea is the same thing. So you have the question, you convert your question to the embedding to a vector. You take that vector, you go to Cosmos DB and search NoSQL, Azure Cosmos DB NoSQL with the vector. You're going to find X number of documents. You're going to take that X number of vectors and documents and send it back to the OpenAI. Well, OpenAI is going to use that to answer your question. So it's going to be more specific about your data rather than the public data. So that's how RAG is going to work. And this is a great example that you can use this data and the code to kind of learn about the process and progress better. So I hope everybody learned something new here today. I learned something new here because I'm not really a Python person, more like C#, but I learned a lot just by just looking at this code here. Also, don't forget we are using serverless. That means we are only paying for what we use, and you can easily run this and show your leaders what you can do with your data by using the Cosmos DB and AI together. And whenever you get okay for a project, or whenever your project is ready to go to production, you can easily convert this or migrate this to provision throughput version of Azure Cosmos DB for more scalability, more resources, and everything will just work fine. So in this case, serverless work great for me. Well, I hope everybody learned something new today, and thank you for watching my video, and please follow me. I'll have more videos like this coming up in the future. Thank you.